In order to properly light up your scenes and levels inside of Unreal 4, you have to understand the 3 different mobility types that are available to the lights in Unreal. So directional lights, spotlights, and point lights all have 3 different mobility types that we can choose. We're going to talk about that now, and I'll show you an example with a directional light representing my sun. So this directional light here is my sunlight, and you can see down here mobility, it's currently set to the stationary mode. And that's the default mode whenever you create a directional light. So what's the difference between a stationary light and, say, a static light or a movable light? Well, if I go here to this drop-down list, I could switch the light to a static light. Static lights, as you can see, well, first of all, I have to build lighting in order for the lighting to actually take effect. So by changing the mobility type, I broke the lighting. If I go to build lighting under the build menu, and I'm just going to build lighting only so that this can go a little bit faster, you see it when it's finished. Here we go. It went ahead and finished building lighting. So now we have shadow maps, as we can see. You can see the shadows being casted by my sunlight underneath the couch, around these different plants and pots and tables and railings and different things like that. So every time you make a change to a static light, you have to rebuild lighting in order to see the updates. This is because these are pre-computed lights, which means that they're basically calculated and rendered first. They're not rendered while the player's playing the game. Okay, now with static lights, we have the ability to change the intensity and the color of the light and any of that stuff. If you change the intensity or the color of a static light, or you move or rotate a static light, you will have to build lighting again in order to see the updates and changes. So here I'm taking this sunlight and I'm rotating it around. I also adjusted the color and all that stuff, and as I make these changes, the light's going to go ahead and break, and you have to go ahead and build lighting again. So let's switch over from static to stationary. A stationary light is kind of a hybrid between static lights and dynamic lights. In order for stationary lights to work, you have to build lighting. This will go ahead and light map the shadows from the light, as well as global illumination and stuff like that. However, we get much nicer dynamic shadows with the stationary light. And we can see already that when I built the lighting, the shadows here underneath my couch by the pots and plants, the shadows being casted by pretty much anything casting shadows in my scene, automatically look much, much better than with the static mobility type. And the cool thing about stationary lights is that they're partially dynamic. Now, you can't move a stationary light without breaking the lighting of the level. So see, if I rotate this light, you'll notice that my lighting broke. Now I have to build lighting again to get the results back that I had before. So the cool thing about stationary lights is that at runtime we can actually change the intensity of the light, and we can also change the color of the light while the game is running. This is something that you cannot do with static lights, but stationary lights allow you to do this. So let me go to my blueprints over here real quick, and I created a very simple blueprint that basically changes the intensity and the color, as you can see here, of my sunlight. And it's going to be very unrealistic, but I'm doing this for display purposes so that I can show you the principle here of what's going on. So this light here can actually change the color and intensity while the game is running. So if I hit simulate to actually run the game, you'll see that I've got this crazy outdoor disco thing going on. But the cool thing here is that my light intensity is fluctuating. So my light's getting brighter and dimmer, brighter and dimmer. It's also changing color, and it's doing that without breaking the lighting. And that's the cool thing about stationary lights, is that they create really nice shadows, and they also allow you to change the light color and light intensity while the game's running. Now if we look at the final mobility type, movable, a movable light is also known as a completely dynamic light. These are the most expensive types of lights to render in video games, because they're completely dynamic and nothing is pre-computed. Everything's being calculated in real time while the game is running. This means that, of course, like we did before, you can have light intensity and light colors change on a completely movable light. You also notice that the light icon changed a little bit there so that I can immediately tell it's a movable light. Now, the final cool thing about these movable or dynamic lights is that you can actually move them around. So I went ahead and created a matinee real quick of this light actually changing its orientation, and I hooked it up to a blueprint. So let's go ahead and let's simulate this, and we'll be able to see that the intensity, the light color, as well as the orientation, the movement or rotation of the light can change on the fly while the game's running. So if you look at the shadows here, the shadows are changing the orientation or the azimuth because I'm actually rotating this directional light, which represents my sun, back and forth. So that's kind of the cool thing about completely dynamic lights. Just remember that they are extremely expensive to render out, so you want to make sure that you're careful about how you're using dynamic lights.